Today we are talking about probability, which are vocabulary words you see here. The first one is experiment. It says in probability, any activity in which results are observed. A trial in probability is an observation of an experiment, and I'll have examples of those for you here in a moment. The outcome is a result of a probability experiment. The sample space is the set of all possible outcomes of an experiment. An event is any set of one or more outcomes. The probability is a number from 0 to 1 or 0% to 100% that tells you how likely an event is to happen. Next is impossible, says can never happen, having the probability of 0. And lastly is certain, which means it has to happen or has a probability of 1 or 100%. Now, yes, we know that we're working on probability. Okay, this next slide right here gives us an example. Now, you don't have to copy all of this down. This does give us an example of an experiment and our sample space. Also, the paragraph here says an experiment is an activity in which results are observed. Each observation is called a trial, and each result is called an outcome. The sample space is the set of all possible outcomes of an experiment. Now, and it gives us an example of our experiment over here and the outcomes that follow each experiment, which is called our sample space. Okay, like flipping a coin, the sample space for flipping a coin is going to be heads and tails because those are the only two possibilities you could have whenever you flip a coin. Rolling a number cube, which is a dice, the sample space can be 1, 2, 3, 4, 5, or 6. So on and so forth. Okay, now let's take a look at our first example. It says give the probability for each outcome. Now, in order for us to discover the probability for these in our table, it's asking us, hey, what's the probability you're going to spin a 1 on this spinner? Well, we can keep this in fraction form because it's going to be easiest on this. So the first thing we need to do is figure out how many sections of our spinner we have. Yeah, we have 8 sections on our spinner, so we know that our denominator has to be 8. And regardless of the number, our denominator is going to stay 8 on this because it wants to know, well, what's the probability you're going to spin, say, a 1? Well, how many 1s do we have on here?
3.
Yeah, we have 3. So our probability of actually spinning a 1 is going to be, 3/8. That is very simple. Now, what is the probability of spinning a 2? Well, if I look back over here, look, I still only have 3. So that would be, 3/8. And then finally, a 3. Well, how many 3s do I have? Yeah, it'd be 2/8. Which on that one, I do need to simplify down to 1/4. Okay, so as you can see, finding the probability for these things is not that difficult. This is simple probability. Now, if I said, what's the probability of you spinning a 1 and then spinning a 2? No, I wouldn't add them together. I would actually multiply them together. If I said, what's the probability of spinning a 1? We'd take our 3/8, our probability of spinning a 1, and then we would multiply that times the probability of the second event occurring, which in this case is still 3/8. So it would be 3/8 times 3/8. Yeah, 9/64. Then we'd simplify that if we could, but that would be our probability of spinning both of those. Okay? All right, let's take a look at our next example. Our next example says a quiz contains 5 true or false questions. Suppose you guess randomly on every question. The table below gives you the probability of each score. What is the probability of guessing 3 or more correct? Now, here's the part where you guys are going to get these wrong. Not that they're hard, okay? It wants to know 3 or more, not just 3. So we need to take our probability of guessing 3, also the probability of guessing 4, and also the probability of guessing 5. Now, if you notice, the number gets smaller and smaller every time. That's the probability of getting smaller and smaller every time. It's saying the probability of you guessing 5 correct answers is not very good. 0.031. That's your probability of guessing 5 correct answers. Notice, your probability of getting them all wrong is also the same as getting them all right. So if you ever take a test and you guess on all of them, it makes you feel any better, you have the same chance of getting 100 as you do a 0. I'm not sure that that makes you feel any better. The chances of that happening are not very good. If you notice, the chance of making really a 50 are your highest. So the probability of getting 3 or more correct, we have to add up all these numbers, okay? We have to add our decimals up. So we have 313 plus 0.156 plus 0.031. Remember, when you're adding up decimals, you have to line your decimals up. Okay? Now once we have that, add them up. 6 plus 1 is 7, plus 3 is 10, 5 plus 3 is 8, plus 1 is 9, 10, and then 5, yeah. So if you notice, we have a 0.5 or a 50% chance of getting 3, 4, or 5 correct. Now, that being said, that means that we also must have a 50% chance of getting 0, 1, or 2 correct, I think, right? I don't know. Yeah. All right, let's take a look at our next one. Let's see. This says a quiz containing 5 true, false. I think these are the same numbers that we were just working with, actually. Now, it wants to know the probability of you passing the quiz, meaning you get 4 or 5 correct. Okay? So, let's figure that out. Well, to determine that, we know that we just have to add those guys up again, because that'll give us our combined probability. Yeah, so you really have about a 19% chance of passing, if you guess, on all of them. Well, that's not very good, but if you think about it, you have a 19% chance of passing, but you have a 50% chance of making a 50. That's not very good. Well, maybe, I don't know. It just says totally guessing. Maybe if you're using educated guesses, maybe it's a little better. I'm not sure. Yeah, I guess. Depends on how educated your guesses are. All right, let's take a look at our, well, I was going to see if this was our last one or not. No, we do have one more, but this one won't take us very long either. So let's take a look at this one. It says use the table to find the probability of each. Well, the probability of finding 1 or 2 occurring, what are we going to do? Yeah, we're going to add those guys up. 0.024 plus 0.327. Add those guys up. 4 plus 7 is 11. 2 plus 2 is 4, plus 1 is 5, and 3.51. So our probability of 1 or 2 occurring is going to be 0.351, or maybe 35.1%. What is the probability of 3 not occurring? What are we going to do there?
Add all the others.
Yeah, we're going to add all of them up except 3. Or what could we do? What do these all have to add up to equal? They have to add up to equal 1. So couldn't we just maybe do like 1.00 minus 1.26? Or 126? That might be a little easier than adding all those up, right? Let me see. So we get our 4 there. 0.874? Sure. Well, I don't know. You could certainly add all those up and give you the same answer. I'm lazy though, so I want the shortest way possible, and I think that's going to be a little bit shorter. All right, and finally, number 3 says 2, 3, or 4 occurring. Well, that means we're going to have to add up our 2, our 3, or 4. So we have our 0.327 plus our 126 plus our 341. And what do we get? Let me see. 14, 5, and 7.754. So as you can see, this stuff today is not that difficult. Really, mostly all we're doing is adding and subtracting because it gives you your tables that you're working with. Just make sure you're answering the question that it asks, because they'll sometimes throw that word not in there. What did I forget? I forgot to add on the second thingamabobber. Oh, I forgot. Oh, yeah. So I did 5. Oh, so it should be 794. Is that what you're telling me? Okay. Thank you. I was wondering why you guys were looking at me so funny. Thought maybe I had something on my face or something. I didn't know. Okay, so it should be 0.794. Thank you. But yes, that's really what we're doing. Not terribly difficult. Anyways, any questions on that? No? All right, get to work because we do have advisory day, so your class is a little bit shorter than usual.